Hello guys, once again welcome to our YouTube channel Edu Hub, and as you know this part 4 of data analysis full course, so without wasting time concentrate on course and let's get started. Data analysis part 4.
Hey, welcome back. So as we've seen, just the Excel data model alone affords us some tremendous advantages relative to traditional methods for creating pivot table reports. Namely, that we are now able to analyze multiple different data sets, as long as they're related that is, in a single pivot. But the data model is really only half the story. Excel's upgraded business intelligence capabilities also include an entirely new programming language called DAX. And this language gives us more power for performing calculations in the data model and your Power Pivot tables than we would have ever dreamed of before. More specifically, DAX is a formula language expressly designed to work with the data model. That is to say, tabular data sets with relationships between them. Now, before you think I'm going off the deep end by introducing an entire programming language in the middle of a course on Excel, just let me reassure you. DAX is actually very similar to Excel formulas and functions, just with a data modeling twist, so to speak. You'll actually find that many Excel functions you know will also work in DAX pretty much unchanged. However, as we'll see later, there are certain DAX-specific functions that only work in DAX. So there are two main ways to use DAX. One is to add new derived columns to the tables in our data model. The other is to create something called measures, which is where DAX really shines. But derived or calculated columns are a bit simpler to tackle, and definitely more intuitive for people whose primary experience is with traditional Excel, so we'll start there. So if you've ever used Excel tables, calculated columns in the data model work almost exactly the same as table formulas, in that they apply to entire columns and create entirely new columns of data. Incidentally, they also have pretty much the same effect as creating derived columns in Power Query, but with the power of Excel formulas and functions at their disposal. In fact, in many cases, you can use Power Query derived columns and DAX calculated columns almost interchangeably. Now, one important thing to note about creating these calculated columns in DAX. The data that results from these calculated columns is stored in the data model and takes up space as a result. So generally, you should keep these calculated columns to a minimum and use them only when necessary. For our first example here, we're going to add a new column to our customers table that combines our first name and last name columns separated by a space. You can imagine that if we wanted to use customer name as a grouping and a pivot, it would be kind of inconvenient to drag in the first name field and then the last name field as separate data points into, say, the rows area or the columns area. So we're going to create a consolidated column that'll be much more convenient to work with in a pivot table. So the steps that we'll follow to create this derived column look almost exactly like creating a calculated column in an Excel table, as I alluded to previously. We'll write a single formula over here under this Add Column heading, and that formula will auto-populate down through all the rows of the table, thereby creating our new calculated column. And the formula syntax itself is going to look exactly like the Excel formulas and functions that you're used to. So now that I've selected a cell under this Add Column heading, I'm just going to type equals, like we would in any other Excel formula. And note how that equal sign now appears in the formula bar above our table, just like in regular Excel. Now we need to reference the value in our first name column. But remember, just like formulas in Excel tables, DAX formulas don't refer to individual cells. They instead refer to entire columns. So I'm not going to try to select cell B2 here. Instead, I need to reference the name of that first name column. And fortunately, DAX is happy to help us with autocomplete, so we typically don't have to type out these entire names. So if I type FIR, right away we see that the first name column from the customer's table is suggested to us. And we actually see it appear again, but just without the prefix of the customer's table. And since we're adding this column to the customer's table, we don't necessarily need that modifier that says the first name column comes from the customer's table because we're already in the customer's table. But just to be explicit, I'll opt for choosing the customer's then first name format. And now I can hit Tab to select that. And then I want to concatenate or add on to the end of that first name a space. So I'll type my ampersand and then a space in between double quotes and then another ampersand so I can glue on the last name. And then adding the last name works just the same as the first name. I can just start typing LAST, and Excel recommends that last name field from the customer's table. So I'll again hit Tab to select that. And at this point I can just hit Enter. And now you see that our calculated column has been created. The only problem here is that Excel gave us an automatically generated name for our column, which definitely isn't descriptive or useful. So we'll want to change that. So to change this to what I want it to be called, which is customer name, I can just double click the column header, delete the existing name, and then just type out customer name. And now if I click out of that, our column's been renamed. So now that we've got our customer name column created, I'm actually going to go back to Excel and create a pivot table that takes advantage of our new column by putting it on rows. So let me go back to Excel, and then here in cell B2, I'll create a new pivot table. And of course, I'll create it from the data model. And then on rows, I think I'll put region. And then I will also add our new field, which does in fact show up in the list of fields in our pivot table field list, which is customer name. And there we are. We have our full and complete customer names being listed under each region in our new pivot table. But of course, our pivot table is kind of lonely here because we're not actually crunching any numbers. All we have is a bunch of row labels. So next, let's create another calculated column that gives us something useful to aggregate in this pivot table. So back to our data model, I'm going to go to our service calls table, and my goal here is to create a summary in our pivot table of the average amount of time a customer call took in minutes. But if you look at our call duration column here, the values are actually in seconds. So what I need to do is create a calculated column that converts call duration from seconds to minutes. Seems like a pretty simple operation, right? We're really just dividing by 60. But there's one additional trick I want to show you here. So after I click under our Add Column heading, instead of immediately proceeding to write the formula, I'm going to click in our formula bar and then type the name I want our column to be, followed by a colon and an equal sign. Then I'll type the formula. Now what this is going to do is establish the name of our calculated column up front, so we don't have to go to the trouble of double-clicking the column header and then typing out the column name. So I'll type call duration minutes, and then a colon, and then an equal sign, and now we can start writing out our formula. And our formula is going to be super simple. We just need to reference our call duration column as the numerator in our calculation. And there we see service calls, call duration. And then we're just going to divide that by 60. So now if we hit enter, there we have it. For each record in our service calls table, we have the duration of that call in minutes. And now we can use this column in the value section of our newly created pivot table. So let's go back to Excel. And now if we look in our service calls table for our new field, sure enough, there it is. So let's drag that into the values area of the pivot. And what we're looking for is the average minutes that each call took per customer and region. So we'll change the way this value is summarized from sum to average, and then we'll tweak the number format so it's only showing us one decimal place. And there we have it. With just a couple simple formulas that don't use any syntax you weren't already familiar with if you're reasonably proficient with Excel formulas and functions, we've created two entirely new fields in our data model and used them to create a more meaningful breakout of call durations by customer than we would have been able to previously. All right, so now that we've added some useful calculated columns to our data model, it's time to explore how we can apply some slightly more complex DAX formulas to creating new columns in our tables. That's up next. I'll see you then. Welcome back. In this one, we're going to quickly review a very useful function that you're likely already familiar with if you've done much work in Excel, the if function. This function gives you the power to take your formulas in one of two or potentially even more directions based on logical tests we define. The basic structure of the if function is this. We feed it a logical test, most typically, but not always, a comparison between two values, and depending on whether or not this test returns a result of true, our function can return one or the other of two expressions. And by expressions, I simply mean either a value or a formula or function that returns a value. I make this distinction because both the logical test and the values that the function returns can all in turn be the output of functions themselves. All the old familiar logical tests can be used. Equals, does not equal, greater than, less than, etc. And there are also ways to strategically combine multiple logical tests in a single if function, as we'll see. Now it's worth noting that in DAX, conditional functions like if are typically, but not always, used to create calculated columns, similar to the ones we worked on in the last video. As such, that's how we'll be applying them. So without further ado, let's dive into some examples. So for our first example, I'd like to add a calculated column to our orders table here that has a 1 if the elapsed time between our order date and our ship date is less than or equal to 3 days, and a 0 if it's not. Essentially, this calculated column is going to tell us whether a given order was shipped within our SLA of 3 days or not. Now, pretty clearly, we have a logical test here, that being the elapsed time between these dates being less than or equal to 3 days, so this is an obvious application for an if function. So to add our column, I'll first click under this Add Column heading, just like in the last video, and then in the formula bar, I'll type the name of our new column first, which will be within SLA, and then a colon, and then an equal sign, and now we can start typing our function. So we'll type if, and then an open parenthesis, and now our logical test will be if ship date minus order date is less than or equal to 3. So I'll start typing the name of our columns, and then minus order date, and then our logical condition, which is that this should be less than or equal to 3. And that's it for our logical test, so we can type a comma, and then the next argument of the function will be what we want to return if this logical test is true. That is to say, there were 3 or fewer elapsed days between our ship date and order date. And that obviously is 1. And then the last argument is what we want to return if that logical test is not true, which is 0. So now we'll close out our parenthesis and hit enter. And tentatively, this appears to have worked, but let's actually filter this column to see a few examples of zeros just to make sure. And now if we look at these orders, it looks like they all have at least 4 days elapsed between the order date and the ship date. So I think our within SLA column is working exactly as designed. So let's unfilter our within SLA column, and then we can move on to a slightly more complicated example in our service calls table. Now here I want to define a similar calculated column, but based on some slightly more complex logic. So there is a similar concept to SLA when it comes to customer calls, which is service level. This basically means that a call was considered acceptable from a customer service standpoint. But the preconditions for this are a little more complicated than for our within SLA field in our orders table. That's because there are actually two logical conditions to consider. On one hand, we want to make sure that our wait time was less than or equal to 30 seconds. But that's not enough. We also have to know that the call was not abandoned, that the customer didn't hang up at some point. So the value in our call abandoned column here needs to be 0. So what we're really looking at is two logical conditions we need to consider. But fortunately, we don't have to write two if statements. Instead, we can use the logical AND operator to combine these two logical conditions in a single if function. So let's see how that works. So again, I'll go under our add column heading, and then I'll start typing my formula in the formula bar. So first I'll type the name of our column, which will be within service level, and then a colon, and then an equal sign as usual. And again, we're using an if function here, so we'll start that. And now our logical test is actually going to be two logical tests combined. The first will be that our wait time value is less than or equal to 30 seconds. So we'll enter the name of our wait time column, and then the condition will be less than or equal to 30. So now, to combine this logical condition with another logical condition such that both of these conditions have to be true for our if function to return that first value instead of the second, we'll use the double ampersand operator, which is Excel's version of the logical AND operator. So we'll type a space after our condition and then two ampersands, and then another space, and then we'll enter our second condition. So our second condition is simply going to say that the value in our call abandoned column must be 0. Basically, the call wasn't abandoned. So we'll first reference that column and simply say equals 0. And there we have it. That is our combined logical condition. And now the rest of the function is going to be very straightforward. If that condition is true, return 1. Otherwise, return 0. And now we'll close out our parenthesis and let's see what happens. And initially, we're seeing a bunch of 1s, but that's because the first several records of our table appear to all meet the criteria for that function to return a 1. So let's just filter for records where a call was abandoned. And it looks like none of these were within service level. And then if we uncheck that filter, and then filter for a wait time greater than 30, so let's just randomly scroll down and select a wait time greater than 30. And it looks like none of those calls are within service level either. So again, it looks like our calculated column is doing what we expect. So in addition to combining logical conditions such that they both have to be true, we can also combine them such that if either one is true, we return the first value in the if function and not the second. So whereas the previous scenario could be described as AND logic, this scenario is more like OR logic. If either this condition or that condition is true, return the first value, otherwise return the second. Now, it's very often the case that you can rewrite a condition that has been expressed as an AND as an OR instead. Sometimes it just makes more intuitive sense to phrase something as an OR versus an AND. So to that point, let's actually refactor our within service level calculated column to use OR logic instead of AND logic. So first, I'll actually click this Clear All Filters button on the ribbon to clear our filter from the wait time column. And then we'll click in our within service level column so we can modify that formula in the formula bar. And now if we think about how we might rework our formula to use OR logic instead of AND logic while still returning the same results, basically we just kind of need to invert our logical operators. So another way of saying that a call is within service level if the wait time is less than or equal to 30 seconds and the call isn't abandoned is to say that if the wait time is greater than 30 seconds or the call is abandoned, then the call isn't within service level. Otherwise, it is. So basically, we're flipping our conditions and we're flipping the order of the two values we're returning in the if function. So that leaves the final question of what is the OR operator in DAX? And that is going to be, instead of 2 ampersands, 2 pipe operators, which is just a fancy way of saying a vertical bar that you'll find on your keyboard. So let's change our first condition to be service calls wait time greater than 30. And then we'll change our 2 ampersands to 2 pipe operators. And then we'll change our call abandon equals 0 condition to call abandon equals 1. And then finally, we'll just flip the order of our 2 return values from 1, 0 to 0, 1. So now our formula logically reads, if wait time is greater than 30, which is a disqualifier for a call being taken within service level, or a call is abandoned, which again is a disqualifier, then we're returning 0. We're saying that call isn't within service level. But if neither of those things occurred, we make it to the second value, which is 1. So let's go ahead and hit enter. And initially it looks like this is working, but again, let's filter on call abandon equals 1 just to verify. And there we have it. It looks like our modified formula worked. So we used AND logic and OR logic to accomplish the exact same thing when creating this calculated field. So one thing I want to point out is that you're not limited to just 2 logical conditions when you're employing AND or OR. You can actually use as many as you want as long as you separate all of the conditions with either the double ampersand or the double pipe operator. Okay. Up next, we're going to learn all about another function that lets us apply conditional logic to our data model, but one that makes dealing with complex, multi-layered conditions far more straightforward than with a traditional if function. I'll see you then. Welcome back. So now that we've brushed up on the mechanics of the if function, let's take a look at a newer and, in my opinion, much improved alternative to if that will make your life a lot easier once your conditional logic starts getting more complicated: the switch function. So there are actually a couple different flavors, so to speak, of the switch function. One that is better suited to straightforward logic that simply tests for equality between 2 values, and then another that can handle much more complicated scenarios. Naturally, we'll start with the simple version. So here in our dates table, we have a field that specifies the quarter of the year, but it just gives us the number. Now, what I would like to add is a more user and report-friendly label for quarter that, instead of just listing the number, has the letter Q in front of the number. So instead of 1, we would list Q1. Now, I could add a column like this via the if function, but the problem is we would have to nest several ifs inside of each other. The first condition might be, if quarter equals 1, return the value Q1. But then the return value of that first if function, if the logical condition was false, that is to say the quarter is not 1, would have to be another if function that would then test to see if the quarter equals 2. Now, nesting if functions even 1 level deep is messy enough, but to go 3 or more just makes them very difficult to read and manage and edit after the fact. So that's where switch comes in. Switch gives us a really straightforward, easy to understand and easy to interpret alternative for this kind of multi-level logic. So instead of discussing the theory behind the syntax, I'm just going to dive right into creating our derived column so we can see the switch function in action. So I'll start with the name of our new column, which I'll call quarter name, and then a colon, and then the equal sign. And now I'll enter our switch function. And looking at the suggested syntax that Excel provides us, we see that the first argument should be an expression. Now in our case, this expression is simply going to be a column in our data, but it could also be the output of some calculation between two columns. In our case, though, we're just keying off the value in our quarter column. So let's go ahead and enter our quarter column for that very first argument. So how this simple version of the switch function basically works is that row by row, it compares the value in that expression we provided for the first argument, which is obviously our quarter field, to whatever we provide in that value1 argument. Then, if the value in our first argument equals the value we entered in the second argument, we return whatever we supply in the third argument, which is result1. So our first level of logic is basically to say, if the value in the quarter field is 1, so we'll enter 1 as our second argument, then return the text string Q1. So far, so good. Now at this point, this may not look all that impressive compared to a conventional if function. But if you think about it, this is the exact point at which, in an if function, you would have to resort to nesting. But in the switch function, there's no nesting required. If I type another comma, we'll see that the next suggested argument is value2. So this is simply another value that I can compare to the expression we provided in the very first argument, which is our quarter column. So I can type 2, and then a comma, and then simply enter what we want to have returned if that quarter value is 2, which will obviously be Q2. And then continuing this pattern, I can type 3, and then Q3, and lastly 4, and then Q4. And then I can close out our function with a closing parenthesis and hit enter. And so now, just to make sure this worked, let me filter for a few different quarters. So I'll filter for the fourth quarter, and it looks like we have all Q4 values. And then maybe I'll filter for our second quarter, and it looks like we have all Q2 values. So again, just think about how much more difficult this would have been with an if function, where we would have had to nest one if function inside of another, whereas here we have this nice, compact, logical, and readable function that accomplishes the same thing. So one thing I want to point out before we move on to the more complex version of switch is that, much like the if function, switch has an else clause, which is kind of a catch-all that assigns a value we specify if none of the logical conditions we lined up were met. So because of that, we actually don't even need these last two arguments of our function, 4 and Q4, because if our quarter is not 1, 2, or 3, we can assume by default that it's Q4. So I can actually remove the 4 here altogether, and what that will do is default our return value to Q4 if the value in our original quarter field is not 1, 2, or 3. The function is smart enough to recognize this pattern of pairs of values and results, and when that pattern is disrupted because we only have a single value at the end of the function after our last pair, our 3 and Q3, the function knows that, oh, that's our else return value. But just to put it to the test, let's hit enter. And then let's again filter for Q4. And our function still worked. Okay, so now that we've got Switch 101 covered, let's move over to our products table to take a look at a more involved example that takes full advantage of Switch's capabilities. So in this table, I would like to create a product category field that looks at the values in our product name field and assigns these to various categories. That way I can track my sales of surfing supplies versus riding supplies like bikes and skateboards versus beach supplies like beach chairs or umbrellas. Now technically we could use the exact syntax that we introduced in the last example for this. The format would simply look like our name column would be the very first argument that all of our logical tests look at, and then you just have a series of pairs of values with whatever we want the category for that value to be. For example, We could say if the name is balsa board, then surfing supplies. If longboard, then surfing supplies. If shortboard, then surfing supplies, and so on and so forth. But as you can see, we have 25 records in our products table, so we would be writing out 25 different pairs of values and return results, which kind of defeats the purpose of using the switch function for convenience and readability. Now, fortunately, there is an operator in DAX called the in operator, which lets us compare a single value against a list of other values. So for example, instead of asking, is the value in our name column balsa board, yes or no, we can instead ask, is the value in our name column either balsa board, longboard, shortboard, softboard, bodyboard, etc., all in one operator, instead of having to create a separate pair of arguments in our switch function for each individual value. Now, the only caveat here is that by default, the switch function only permits simple tests of equality. That is to say, we can't use more complex logical tests like greater than, less than, or, in this example, the in operator. But fortunately, as we're about to see, there is a workaround, and that is to make the first argument of our switch function the true function, which simply returns the logical value of true. Don't worry too much about why this is the case. Just remember that if you want to use more complex logical conditions than simple equality in your switch functions, the very first argument of your function should be true. What this does is not only allow us to use more complex logical operators, but it also removes the restriction that we can only compare a single value at all the levels of our switch function. So before, we were limited to just using values from a single column, but with this approach, you can perform logical comparisons on as many different fields as you want. So with all that said, let's see how this works in action and create our new product category field. So I'll name it product category. And then of course our colon and equal sign. And then we'll enter our switch function. And now, again, for that very first argument, instead of entering a column that we want to perform our logical tests against, we're instead going to enter the true function. And that will require an opening and closing parenthesis. And then for our value and result pairs, instead of our value simply needing to be just that, a value, it can actually be a logical comparison. So we can say name, and then the in operator. And now what we're going to do is test to see if the value in a given row is in a list of names that we specify. So the syntax for the in operator is just slightly funky. Instead of using parentheses after it, you use brackets, these guys right here. So now within those brackets, I simply need to create a list of the things that I want to test whether the name in our given row belongs to. So I'll start by typing balsa board, and then longboard, and then shortboard, and then softboard, and then bodyboard, and lastly, skimboard. I'll spare you any further typing now that you hopefully have the point of how this works. So this entire expression is all still just our second argument of this function. This is basically a logical test. It says if the name in our products table for a given row is one of these, then return some value. And we specify that value in the very next argument. So for my return value, I'll say surfing products. And at this point, I could absolutely continue to write out more comparisons involving this in operator until we finally have accounted for every single name in our products table. But just for the sake of demonstration, I'm just going to include an else clause here that will say all other products, and then close out our parenthesis and hit enter. And now if we look at our products, we see that our first 6 products are all listed as surfing products because those are the ones that we included in our in list. And the rest of our products are all categorized among all other products. So now that you get the idea, I'm going to go ahead and finish writing out our switch statement here, but I'm going to fast forward the video because there is a lot of typing and I'm not an especially fast typist. Now, to make room for what is still going to be a pretty long formula, I'm actually going to click this little down arrow to the right of the formula bar here to give myself a little more room to write the formula. So now, right before our else argument, after our very first pair of logical condition and then return value if that condition is true, I'll just start writing out more logical conditions and more return values until all of our products in the table have been covered. Okay, so after a lot of typing, I've finished up my switch function here. And if you look down through our product category field, it looks like our categories are being assigned correctly and make sense. Our beach cruiser bicycle is listed under riding supplies. Our various surfboards are listed under surfing products. And then our other more miscellaneous products are listed under beach supplies. Now, I do want to note that while this made for a good example of the power of the switch function, in a case like this, where you're trying to assign categories to a list of things, another option might be to simply create a separate lookup table that you could then join into this table. So for example, I could have created a product category table in which I listed these categories and then joined that into my products table to achieve the same result. Generally speaking, the decision of whether to handle something like this with a switch statement or a lookup table depends both on your personal preference and also the granularity and complexity of the logic. If you find that your switch functions are getting really messy, and you could argue perhaps that this one is, it might be time to refactor that out into a separate lookup table. Okay, so up next we're going to switch gears just a bit by looking at a function that allows us to reference columns in other tables as we're creating our calculated columns. I'll see you then. Hey, welcome back. So sometimes, as we're creating calculated columns in our data model, and later on, as we'll see, also measures, but don't worry about those just yet, sometimes we need to access columns in tables other than the one we're adding the calculated column to. Consider our formula for within SLA in the orders table here. Now let's say we wanted to modify this logic to include a special accelerated shipping timeline for our loyalty club members. Now we do have a field in our data model that tells us whether a customer is in fact a loyalty club member, but the problem is it's not in this table. It's actually in the customers table. So how can we get access to this data so we can incorporate it in our modified formula logic in the orders table? The answer is by using DAX's related function, which takes advantage of the relationships between the tables in our data model. So switching over to our data models diagram view, and then zooming out a bit just so we can get the big picture, we see that there is in fact a relationship between our customers table and our orders table. Now, because this relationship exists, we can in fact access fields from our customers table and use them in calculated columns in our orders table. Now, it's not just that these tables are related that enables us to do this. It's also the nature of the relationship and which table is on which side of the relationship. So the related function needs to return exactly one value per row of the table that we're using it in. So let's say, for example, I tried to use the related function in our customers table to pull in values from our orders table. Now there's a one-to-many relationship between our customers table and our orders table, which means that a single customer ID in our customers table might have several matches in our orders table. So to pull a field from our orders table back into the customers table would mean potentially pulling in multiple values per customer ID. Now obviously that doesn't make a lot of sense, if you're trying to retrieve a single value, and for that reason, the related function can only be used to fetch values from the one side of a one-to-many relationship into the many side. So from our orders table, we can fetch fields from our customers table, and also, in fact, our states table and our regions table. But we cannot fetch values from our orders table into our customers table, or from our customers table into our states table, or from our states table to our regions table. We always pull from the one side of the relationship into a table on the many side. So now that you understand the rules of the road for using the related function, the actual syntax is super straightforward. So to put it to work, let's go back to the data view of our model, and then go to our orders table. And now, before we get to work modifying the logic of our within SLA calculated column, I'm actually going to use the related function to just fetch in that loyalty club member value from our customers table. So over here under our add column heading, I'll create a new calculated column, which will basically just be that value from the customers table. So I'll call it loyalty club member. And then I'll add the requisite colon and equal sign. And now I'll type out the related function. And as you can see, this function takes a single argument, which is just the name of the column that we're pulling in from a different table. Now, obviously, because we're pulling the column in from a different table, it's especially crucial that our column reference has the name of the table in front of it. And actually, if we look at our list here, we see our loyalty club member field from our customers table, the fifth one down. So we'll arrow down to select it and then hit tab. And then we'll just close our parenthesis and hit enter. And now we have those values from our customers table available to use in our orders table to support the logic of our within SLA formula. Now the cool thing is, we don't have to actually have a standalone column for a loyalty club member in our orders table to get this to work. In fact, I can just include the related function in our within SLA logic, so we can skip this intermediate step of adding an entirely new column to our table that's really just taking up space. So I'll delete our loyalty club member column just by clicking it to select it, and then right-clicking and choosing delete column. And now I'll click in our within SLA column so we can go ahead and start modifying our formula. Now currently we're employing an if function for this calculated column, but since we're adding some complexity to our logic, I'm going to flip that over to a switch function. Now our logic's basically going to be, if the customer associated with this order is a loyalty club member, that is to say the value of that loyalty club member field is 1, and the difference between our ship date and order date is less than or equal to 2 days, then we will say that our order was within SLA. Otherwise, we'll say that our order was within SLA if the difference between the order date and ship date was less than or equal to 3 days, which is the logic we currently have. Basically what we're doing is making sure that we have a more aggressive SLA for those loyalty club members of just 2 days to reward them for their membership. So I'll just overwrite this entire formula here and start out with a switch. And because this is going to be the complex variation of switch where we have multiple different logical conditions, my first argument will just be the true function. Now for our first logical condition, we're going to spell out the conditions under which a loyalty club member's order would be considered to have been shipped out of SLA. And that's basically if the customer associated with the order is a loyalty club member and the order was shipped more than 2 days after it was ordered. So spelling this out, we'll start by using our related function to fetch that loyalty club member field from the customers table. And then we'll make sure that that is equal to 1, indicating that the order was placed by a loyalty club member. And now because we're combining this condition with another condition, we'll need to use our AND operator, which is again just our 2 ampersands. And then the second piece of this condition is specifying that the elapsed days between our order date and our ship date are greater than 2. That's that accelerated timeline that we want to provide to our loyalty club members. So we'll say ship date minus order date greater than 2. So now if both of those conditions are true, we want to return a 0, indicating that the order was not shipped within SLA. So for our second condition, we're going to account for basically all the other orders. So this logic is going to look pretty much like the logic in our original if statement. So we'll say ship date minus order date greater than 3. So for all other orders, if the difference between the order date and the ship date is greater than 3 days, then we'll return a 0, indicating again that that order is out of SLA. And then finally, our default case, meaning that the order was shipped within SLA, will just be a 1. So now I'll close that parenthesis and hit enter. And now that our formula has finished calculating, to put it to the test, I'm going to filter our table here by aging bucket equals 3 days. Now, based on our original logic, all orders shipped within 3 days should be within SLA. But right away, we see multiple orders here that are being flagged as being out of SLA, including our very first one here with customer ID 18543. So if we go over to our customers table and filter on customer ID 18543, sure enough, that customer is a loyalty club member. So it looks like our modified formula is working exactly as we intended. Okay, so we've already seen how DAX formulas and functions can allow us to do some pretty interesting things when it comes to adding calculated columns to the tables in our data model. But when it comes to DAX, we have barely even scratched the surface. That's because DAX's primary application in the Excel data model is creating something called measures, which are basically portable calculations that we include in the values areas of our pivot table and give us tremendous power to include complex calculations right in our pivot tables. We'll dive into measures starting in the next video. I'll see you then. Hey, welcome back. So now that we've established a foundation in DAX, it's time to turn our attention to the most important application of DAX, measures. So what the heck are measures? Well, basically, they're formulas that you add to a pivot table. But beyond that, there's a lot of things that make them special and unique above and beyond any calculations we've been able to do in pivot tables up to this point. For one thing, measures are portable, which means that you can define a measure in one place and then use it in multiple different pivot tables. Now, if you've ever used calculated fields in pivot tables, measures are somewhat similar to those, but far, far more powerful. Instead of being limited to just adding the standard count or sum or average calculations that we've included in our pivot tables until now, measures allow you to leverage the power of DAX to add sophisticated, reusable calculations to the values area of a pivot. Calculations that, again, go far beyond the counts and sums and averages we've used up to this point. So now that we have an idea of what measures are, let's flip over to Excel and add our first measure to the data model. So here in our starter file, to create our first measure, I'll first go to our Power Pivot tab on the ribbon, and then on that contextual tab, I'll hit the Measures button. And now we have the option to either create a new measure or to manage existing measures. Obviously, this is our first measure, so we'll hit New Measure. And now Excel presents us with a dialog box that will walk us through the process of creating a measure. And we'll just take this one input at a time. Now, the first thing we're prompted to input is a table name. So measures are assigned to tables, but the choice of that assignment is entirely up to you. However, you should ideally assign the measure to whatever table contains the value that is being calculated as part of the measure, assuming that there's only one. Now, sometimes there are fields from more than one table that may be involved in the measure, in which case the selection of the table is more of a judgment call. Now, in our case, our measure is going to be the average of the call duration minutes field from our service calls table. So because we're averaging a field from the service calls table, we'll choose that table from this drop-down list. Next, we're prompted to give the measure a name, which, just following common sense, should be meaningful and descriptive. And I think I'll call it average call duration minutes. Optionally, you can also enter a description for the measure, which can provide some additional insight into what the measure's purpose is or how the calculation works. But for this simple measure, we'll skip that step. And now that finally brings us to the most important part, which is actually writing the formula. Now you'll find that this works a lot like writing formulas anywhere else in Excel, whether it be a worksheet cell or adding calculated columns to the tables in our data model. We get all the goodies that come standard with writing formulas in Excel, from assistance with formula syntax to autocomplete for the fields we're referencing. So again, our particular measure is going to be the average of call duration in minutes, but keep in mind that there is an absolutely enormous variety of functions you can use in your measure calculations. And even though we'll be covering several of these, we're still just scratching the surface. One thing that is important to keep in mind going forward, however, is that you must apply some sort of aggregation to any column from the data model that you reference in a measure. Measures are specifically designed to go into the values area of a pivot table, which of course is where we traditionally did our counting, summing, or averaging of fields in our data. But with measures, we don't define the aggregation in the pivot table. Instead, we define everything, from the formatting to the function we'll use to aggregate a field, up front. Make sense? Now looping back to our current example, we're using an average function to aggregate call duration in minutes. So we'll start typing the name of our average function, and we see that Excel suggests the function that we're looking for, so we'll just hit Tab to select. And since the average function, as applied to our data model, takes a single column as its argument, our measure window is smart enough to simply list all the columns in our data model. Now we're interested in taking the average of the call duration minutes field, so I'll arrow down to select that one and then hit Tab to lock it in. And finally, I'll close our parentheses. But before we click OK and officially add this measure to our data model, I'll first hit this check formula button that just makes sure there won't be any errors with our calculation. So if I click that, Excel confirms that there are no errors in our formula, so we should be good to go. Now as a final step, I can also add formatting to our measure, which means that wherever we drop this calculation in whatever pivot table, the formatting I specify here will be retained. So you don't have to worry about formatting the measure wherever you choose to put it. So since this is going to be an average of numbers, I'll choose a number format, and I'll elect to have one number after the decimal place. So finally, I think we're good to go ahead and click OK. So now we've created our measure, but where exactly is it? Well, if we go to our data model, and then go to our service calls table, which is the one that we assigned our measure to, you'll see that in this first column of our data model, our average call duration measure is listed. So now we know we didn't go to all that trouble for nothing. We have our measure stored in our data model. So the next step is to use it by adding it to a pivot table. But before we do that, I'm going to create a pivot table that summarizes average call duration the quote-unquote old-fashioned way, just so we can see the results side by side. So I'll close out of our data model, and then insert a pivot, and then I'll put region on rows, and for our values, I'll summarize call duration in minutes from the service calls table. And I'll summarize that as an average. So now that we've crunched out average call duration in minutes the traditional way, let's throw our new measure into our pivot table and see how that looks side by side. So still under our service calls table in the pivot table field list, we now see below all the other fields in the table, the name of our measure preceded by this little FX symbol. So because we assigned that average call duration minutes measure to our service calls table, We see it listed as just another field available to us in that table. And that little FX symbol just lets us know that this is a measure and not a conventional field from a table. So now we can just grab that measure and drag it right into our values area. And we see that we have the same results that we got from dragging in the raw call duration minutes field, but without having to go to the additional trouble of specifying how the field should be summarized as a sum or an average, or how it should be formatted. We defined all of that stuff up front in the measure so that when we dragged it into the pivot table, everything just worked. Now it's worth noting that our existing calculation in our pivot table is technically also a measure, but it's what's known as an implicit measure. Basically, whenever you summarize anything in the values area of a pivot table, you are technically creating a measure. But if you don't define that measure explicitly, like we just did with our average call duration minutes measure, it is an implicit measure, which means you don't have access to all the power of the DAX programming language, nor do you have the ability to predefine the formatting of the measure or to add it to multiple different pivot tables. For this reason, I highly recommend defining measures for any calculation you do in your pivot table. There's really just no downside. You never know when you might want to add the same measure to a different pivot table, and having your calculations defined in one place doesn't just save time, but also enforces consistency and data integrity when creating multiple pivot tables. Now, it's important to note that the same rules of data modeling that applied to calculations in our pivot tables before apply equally to measures that we create with DAX. So basically, all your intuition and understanding about how to create power pivot tables from the data model still applies to measures. We now just have the ability to take those calculations way further. So just to underline the portability of measures, I'm going to create a whole new pivot table here, and then add our new measure to it. So I'll close out of our field list here, and then click a different cell, and insert a new pivot. And for this pivot, I'll put product on rows. And then in our values area, I'll simply add our new measure from our service calls table. And then if we close out of our field list, you see that in just a few seconds, I was able to create an entirely new pivot table with this exact same calculation, but broken out in an entirely different way. Again, underlining the power of the portability of measures in DAX. Now, another advantage this can have is that if we decide to change our measure in any way, that change will cascade down to any pivot table that we have added that measure to automatically. So if we decided to change the logic of our calculation, or the formatting of our measure, or the name of our measure, we would simply have to do that in one place, as opposed to needing to worry about updating multiple different pivot tables. This allows us to follow one of the biggest commandments of programming and development, which is the dry principle, or don't repeat yourself. You normally don't associate programming methodologies and paradigms with a spreadsheet, but that's how much power DAX and measures give us. So just to demo that, let's try editing our measure to show 2 numbers after the decimal place instead of 1. So back to our Power Pivot tab, we'll click our Measures button again, but then instead of selecting New Measure, we'll go to Manage Measures. And obviously we've created one measure thus far, so we'll select that and hit Edit. And now under our formatting options, I'll change our decimal places from 1 to 2, and then click OK. And as you can see, both of our pivot tables updated automatically. In my opinion, pretty darn cool. All right, now that we've covered Measures 101, up next, we're going to take a look at applying some DAX-specific functions to our measures. I'll see you then. Welcome back. So one of the cool things about DAX is that many of your favorite Excel functions work pretty much the same in DAX as in regular Excel, just on entire columns of data as opposed to individual cells. But there are also plenty of functions that really only make sense in the context of the data model. Now in this course, I'm assuming you know your way around the most common Excel functions, so we're going to focus on DAX-specific functions from here on out. We'll start with a couple of relatively straightforward, yet still very powerful functions: count rows and distinct count. So count rows does pretty much what it sounds like. It counts the number of rows in a table. Distinct count, on the other hand, takes a column as its argument and returns a count of the unique items in that particular column. So say we have a table with 30,000 rows, but then we have a column in that table with something like product category that only has 5 distinct product categories. Our distinct count function would return the number 5. So let's go ahead and use these functions to create some new measures in our data model. Starting off simple, I'll create an order count measure that simply returns the number of customer orders we've taken. Now, since the orders table in our data model contains one record for every customer order, our order count measure can simply be a count of rows in that table. Seems like an obvious use of the count rows function. So to create our measure, I'll again click our measures button and then new measure. And because this measure pertains to the orders table, I'll assign it to that table and I'll call it order count. And then for our formula, I'll use the count rows function. And as I mentioned, it takes an entire table as its argument. So we can start typing out the name of our orders table. And there it is. So we'll close our parenthesis and then hit check formula just to make sure everything's going to work. And then finally, we'll format our measure as a number. And because we're dealing with a count here, we don't need any digits after the decimal, but we will use the thousand separator. And then click OK. And now to see how this measure works for us, we'll use it in a pivot table where we break out order count by region. So I'll insert a new pivot table, and then I'll drag in region on rows, and then I'll look for our measure under our orders table, and there it is, order count. So we can drag that into values, and there we are, a quick and easy breakout of order count by region. Now next we'll do something slightly more interesting and more difficult to pull off in a conventional pivot table. And this will involve our distinct count function. Now what we're going to try to do is to create a measure that returns a count of the number of unique days on which we sold products. So regardless of how many orders we had, if we've only been selling product for a year, and out of the entire year there were only 350 days on which we made at least one sale, our distinct count function on our order date field would return 350 because it's returning the count of unique values in that field. Now this measure may not seem to have any obvious value, but you'll see how we'll be able to leverage it in just a minute. So to create our measure, I'll go back to our Power Pivot tab, hit the Measures button, New Measure, and again, this measure pertains to data in our orders table, so we'll assign it to the orders table, and we'll call it number of days products sold. Now for our formula, we'll use our distinct count function. And as you can see, this takes a single argument, which is just a column of one of the tables in our data model. Now what we want to do is return a count of the distinct values in the order date column of our orders table. So if we scroll down, we see that field in our orders table. So I'll double click that to select it, close our parenthesis, and then hit the check formula button as usual. And again, because we're dealing with a count, I'll choose a number format, no digits after the decimal, and a thousand separator, and then click OK. And now looking at our pivot, where this measure was automatically added, we see that in many cases, the number of days our product was sold is very different and much less than the actual order count, which makes sense because there most likely are many days on which more than one customer order occurred. So all of those different orders are being tabulated in our order count measure, but only the unique days on which those orders were placed are being counted in our number of days product sold measure. Now on its own, this number of days product sold measure again probably doesn't seem too useful. But what I haven't told you yet is that you can actually use measures as building blocks to create other measures. So now that we have these two measures here, we can actually use them in a calculation to create a third measure, which can provide us some more interesting insights into our customer orders. Specifically, we can divide our order count by our number of days product sold to get an average of the number of orders placed per day, which I think you would agree is a fairly useful measure. So let's see how that would work. So again, I'll create a new measure. And since our building blocks are two measures that are already assigned to the orders table, it only makes sense to assign this one to that table as well. I'll name the measure orders per day. And then for our formula, I could simply divide one measure by the other. But the problem with simple division is that, as you probably know, if your denominator is 0, that will trigger an error. Now in traditional Excel formulas, you'd have to resort to some kind of an if error function or an if function that tested for the condition that the denominator is 0 to avoid this kind of situation. But DAX gives us a function called divide that allows us to return an alternate value in the event that there is a division error. In fact, divide is such a useful function, I recommend pretty much using it universally anytime you're doing division in your DAX formulas. So I'll start by entering the divide function. And as you can see, the first argument is the numerator, the number on top of the fraction, and that's going to be our order count. So if I just start typing the name of our measure, we see order count pop right up, and we know it's a measure because of that little sum icon to the left. So let's hit tab to enter that, and then a comma. And then for our denominator, we'll enter our second measure, which is the number of days products were sold. So I'll start typing that name. And as you can see here, nothing's happening. We're not getting any formula autocomplete suggestions. And that's just because we started the measure name with a pound symbol, so DAX is unhappy about me referencing that name without putting it in brackets. So let's backspace and type an opening bracket, and then type a pound sign, and there's our measure. So we'll hit tab to select that one. And now the third argument, and this is what makes the divide function so cool, is what we want to return in the event that there's a division error. Now the obvious option is the number 0, but I personally prefer to use another DAX function called blank in this argument. Now blank will simply return exactly what it says, just a blank if there is any division error, which strictly speaking is more accurate than a 0. If there's a division error, there's really no number that's returned at all. So for our third argument, we'll enter that blank function, and Excel auto-populated the parentheses for that function. So now we'll enter our final closing parenthesis for our overall function, and then hit check formula as usual, and everything looks good. Now because we're performing a division calculation here, we'll probably want to format our number to at least have one number after the decimal place. And we're probably dealing with small enough numbers that we don't need to worry about a thousand separator, so we'll go ahead and click OK. And this measure has been automatically added to our pivot table as well, and if you look at the results, they appear to be accurate. For the one region where we had the same number of orders as there were days that products were sold, our orders per day number is 1. But for most regions, the number is much higher, just as we would expect. And in case you think that for some reason we need to keep the two measures that this measure is based on in our pivot table in order for it to work, let's go ahead and cut those guys out. And as you can see, the measure still works. And I can't emphasize enough that you're not limited to using just a single layer of measures as you're building measures on other measures. It's quite common in the real world to have long chains of dependent measures, where measure A is built from measure B, which is built from measure C, and so on and so forth. And the best thing about this, as we'll see later, is that if you change the logic of a measure, all dependent or downstream measures will reflect that change automatically. Okay, now that we've gotten our feet wet with some DAX-specific functions, it's time to dive into perhaps the most important function in the entire DAX language: calculate. That's up next. I'll see you then. Hey, welcome back. So in this one, we're going to learn all about one of, if not the single most important function in all of DAX, which is the calculate function. So if you've ever used the SUMIF function in Excel or any of its cousins like averageIf or COUNTIF, you're familiar with the concept of a function that can perform a calculation conditionally. That is to say, some data points are included in the sum or average or count calculation and some are not. And even if you haven't used those functions, the concept is fairly straightforward. You have a calculation, like a sum, an average, or a count, that is performed contingent on some condition being true. So if we have a table with product sales with, say, 100 rows, we can use a function like that to sum or average product revenue, for example, for only certain specific products. In this way, we are performing that calculation conditionally. Now, the problem with those functions before is that you were limited to the somewhat very straightforward calculations that were baked right into the function's name: sum if, average if, and so on. Well, now with calculate, we have access to a function that you can think of as a kind of anything if. A sum if on steroids, if you will. Calculate allows us to apply any of the measures in our data model, or any custom calculation that would qualify as a measure, conditionally, based on certain criteria that we specify. So the calculate function allows us to take the measures we've already defined, or new ones that we choose to define right in the calculate function, and then apply them conditionally. So now let's take a look at exactly how that works in a Power Pivot table, and then we'll move on to a useful example. So here we have a fairly straightforward pivot that just breaks out revenue by product name. Now, our very first attempt at dipping our toe into the calculate water, so to speak, will be to create a measure that calculates our revenue measure, but contingent on our product name being beach umbrella. So let's go to our Power Pivot tab, and then create a new measure. And because this pertains to revenue, and the revenue measure is stored in our order details table, I'll assign this new measure to the order details table as well. And for now, I'll just call this umbrella revenue. And then for our formula, we'll start by typing out the calculate function. And now our expression, again, is either an existing measure or a new expression we define that could qualify as a measure. Now, in our case, we're trying to apply a filter to our existing revenue measure, so we'll enter our revenue measure. And then the next argument will be the filter that we're trying to apply to that measure. That is to say, the logic that defines which records we're going to apply our measure to and which ones we're not. So for our purposes, our filter is products with the name beach umbrella. So after typing our comma, we'll search for the name field from our products table. And now our condition is going to be that this column equals the string beach umbrella. And because our criteria is a string, we'll need to put it in double quotes. And then we'll close our parenthesis and hit our check formula button. And it looks like we don't have any errors. And since our calculate function is just going to return a filtered version of our revenue measure, we'll format our new measure as currency, and then click OK. And now let's go ahead and add this new measure to our existing pivot table, right alongside our existing revenue measure. So over to our Pivot Table Analyze tab, I'll display our pivot table field list, and then roll down to our order details table, and then drag in our new umbrella revenue measure. Now, if this looks a little bit weird to you, you're not alone. Plenty of people are quite puzzled by the behavior of the calculate function the first time they see it in action. So if you look at the revenue amount for our beach umbrella product in our original revenue measure, that exact same number, $346,335, is being repeated for every single row of our pivot table in our umbrella revenue measure. So what's happening here? So the key thing to remember about calculate is that any filters that we specify in the function, in the measure definition, override any filters on the same field in our pivot table. So if you recall when we discussed the concept of a cell in a pivot table having coordinates or an address defined by where they sit relative to any row labels, column labels, or filters in the pivot, and how those row labels and column labels effectively apply filters to the numbers in our pivot table, our calculate function overrides those filters if there is a contradiction between the filter that we specified and the filter in the pivot table. So in this case, we applied a filter to the product name field. But our pivot table is also broken out by product name. So what happens? Our calculate filter charges in there and overrides the filter our pivot table is trying to apply. So in the very first row, our pivot table is saying filter the revenue measure by balsa board. But for our umbrella revenue measure, because we've already specified a filter on that exact same field, our specific filter, which says product name equals umbrella, overrides the filter being specified by the pivot table. And the result is we get the exact same number for every single row, that being the number resulting from our revenue measure being filtered for just the product beach umbrella. So one lesson to take away here is, if you have a measure that you've created with calculate that filters on a specific field, it generally doesn't make a lot of sense to have that same field in the pivot table that you're putting the measure in. Because now you're going to have the situation of pivot table filters competing with and then being overridden by the filter that we specified in our calculate function. So for example, if I swap in a different field on rows in this pivot table, like say for example region, now we get some more sensible results. So for our East South Central region, for example, that $31,297 revenue for umbrellas is actually a meaningful number. That is the amount of revenue we made strictly from beach umbrellas in the East South Central region. So our new measure is able to generate a meaningful number as long as we don't put it in competition with the same field we're filtering on by dragging that field into the row or columns area or even the filters area of our pivot. So now that we have the basics of calculate down, let's move on to a slightly more interesting example. So let's say that we would like to track revenue by product for our customers who are loyalty club members versus all customers as a whole. So with the calculate function's ability to filter a measure like revenue based on something like whether a customer is a loyalty club member, this should be pretty straightforward. So first, we'll go back to our Power Pivot window and create a new measure. And for the name, I'll go with LCM revenue for a loyalty club member. And then for our formula, we'll type calculate. And then just like before, our expression will just be our revenue measure. And then our filter is going to be that the loyalty club member field from our customers table equals 1. And because that 1 is a number and not a string, we don't have to put quotes around it like we did in the last example. So now I'll close that parenthesis, hit check formula. And because again, this measure is just returning a filtered version of our revenue measure, we'll format as currency and then click OK. And to make it a little bit easier to compare our loyalty club member revenue to our overall revenue, I'll go ahead and remove our umbrella revenue measure. And there we have it. A nice side-by-side comparison of overall revenue versus loyalty club member revenue. But because we've defined our LCM revenue as a measure, we can also use that measure in a calculation that creates yet another measure. For example, I can now easily crunch out the percentage of our overall revenue from just loyalty club member customers. So to do that, I'll create another measure, and I'll call it LCM revenue percent. And for this measure, I'm simply going to divide our LCM revenue by our overall revenue. So I'll use the divide function. and then just divide our LCM revenue by our overall revenue. And then for my alternate result, in case there is a division by zero error, I'll just enter the blank function. And then I'll close our parenthesis, check formula, and because our new measure is a percentage, we'll format as a number, and then as a percentage, and then click OK. And now we can see a breakout of what percentage of our overall revenue was driven by our loyalty club members by region. And because this measure did not involve any filters on the product field, I could just as easily swap products in on rows instead of region. And just to prove that, I'll remove our region name from the pivot and then swap in product. And as you can see, no issues. Now, one thing I would like to clarify before we go is that you're not limited to applying a single filter or criteria in your calculate functions. In fact, you can list as many as you want, giving you extremely fine-grained control over those measures. So let's say I want to see loyalty club member revenue for just our South Atlantic region, but broken out by product as we see here. Now this will involve applying filters to two different fields from two different tables. But because the filters I'm applying are both from tables that are related to the field that we're filtering via one-to-many relationships, and because they don't conflict with any of the filters in our pivot table, it should work just fine. So I'll create one more new measure, and I'll call it LCM Revenue South Atlantic. And then for our formula, first the calculate function, our revenue measure, we'll make sure our loyalty club member field is 1. But now if I type a comma, you see that we have the option to enter an additional filter. And again, you're not limited to just 2. You could keep adding more and more filters, as many as you need to get to the logic you want. And in our case, that will be region name equals South Atlantic. And now I'll close our parenthesis, check formula, format as currency, and hit OK. And now if I move that measure up 1 in our pivot table, just so we can see it side by side with our overall loyalty club member revenue, you'll see that the number is substantially less, about what we'd expect for revenue from one region versus all regions combined. So I hope at this point you have some appreciation for just how much control over your calculations the calculate function gives us. And while we've only explored using it in the context of a single measure, that being revenue, we could actually have used any of the measures that we've created thus far or defined our own right there in the calculate function. Okay, so in this video, we looked at how to filter measures by applying criteria to specific fields in our data model. Criteria that override the filters in our pivot tables. But in the next one, we're going to learn to do the exact opposite. We're going to learn how to do, in a sense, the opposite of filtering in our calculate function by removing any filters that are being applied in our pivot tables. I'll see you then. Welcome back. So the thing about the calculate function we learned in the last video is that it's really just a vehicle for us to combine sophisticated custom measures and calculations with sophisticated custom filters which apply to those calculations. Now, one flavor of filtering, which is the one we explored in the last video, is to require that the values in a column of our data meet some logical criteria. We essentially apply our own filter that adds to, and potentially overrides, if there's a conflict, any filters coming from our pivot table. So looking at this example from our last video, in the first column we have our standard revenue measure, and the only filter being applied to this revenue measure is the values in our rows area, which are region names. But if you look at the values from our loyalty club member revenue measure, they're consistently quite a bit smaller. And that is because in addition to the filter being applied by the pivot table, that being a different region name for each row of the pivot, our measure itself has another filter baked in, which says that the order must have been placed by a loyalty club member. So in this way, the method of filtering we learned in the last video adds or overrides filters. But another approach, which has its own set of applications, is to remove any filters being applied by a specific column or columns within our pivot table, without replacing those filters with any of our own. A measure defined in this way is immune, so to speak, to any filtering from any part of our pivot, rows, columns, filters, or slicers, involving a column or columns that we specify. And DAX's all function is the way that we accomplish this. So the all function is typically used within a calculate function as that second filter argument to specify a field or fields that should not be included in the filter context of that measure. Basically, it works like the filters we applied via calculate, but in the exact opposite direction. Instead of filtering our measure by a field, it instead removes all filters from a specific field, regardless of the layout of our pivot. So this can be a difficult concept to get your head around without seeing it in action, so let's dive right into an example to see how the all function works. So first up, I'll remove these existing measures from our pivot table and replace them with order count. And because at this point we've added quite a few measures, I'm actually going to change the layout of my pivot table field list to make it easier to find my measures. So I'll click this gear icon, and then I'll choose this Fields section and Areas section side by side option. And this gives me a little bit more room to view the fields and measures that I have available to add to my pivot. So first I'll remove revenue and LCM revenue, and then for my orders table, I'll add order count. Now next I want to define a brand new measure, which will basically be our order count measure, but immune to any filters applied to it by the region name column. So the goal is, no matter where we have region name in our pivot, whether it's the rows area, the columns area, or the filters area, that field will not be able to filter our order count measure. So let's see how this works. We'll first go to our Power Pivot tab, and then add a new measure. And since this pertains to orders, I'll drop it into our orders table, and I'll call it order count all regions because we're removing any filters applied by region. And now for our actual formula, I'll first type calculate, and then our expression or measure will just be our existing order count measure. And now here is where the all function comes in. Instead of specifying a filter on a field, we'll invoke the all function. And as you see, we're prompted to enter a table name or a column name, although to be precise, we should generally enter a column name. So the field that we don't want to be filtering our order count measure is region name. So at this point, we can close the parenthesis on our all function and then our calculate function. And then we'll check our formula. And then since this is going to give us a count, we'll format it as a number and then a whole number. And we'll use our thousands separator and then click OK. Now, if you compare the numbers that you're seeing for every row of our pivot under our new measure to our grand total, I think you'll get some idea of what's going on here. Because we told this particular measure that we don't want any filters coming from our region field to apply to order count, and because our pivot table happens to be broken out by region, every row simply reflects the grand total. Because when, for example, in the first row of the pivot, our pivot table comes in and tries to filter that order count measure by region equals east, north, central, our all function rejects that filter harder than Dikembe Mutombo blocking a shot. Now just to underline how this all function only applies specifically to the field that we fed it as an argument, let's swap in a different value in our rows area. Let's say states. So we'll go down to our states table and first get rid of region from our rows area, and then drag in states. And now you see that our order count all regions measure is returning the exact same thing as our standard order count measure, because what we told the all function was to remove any filters coming from the regions field only. So when we filter our pivot table by something else, the measure works just the same as the standard order count measure. Now for this reason, when you're using an all filter in a calculate measure, you'll typically want to filter your pivot table in some way by the same field that you're excluding in your all function. Otherwise, it basically has no effect. But at this point, you might even be questioning the value of the effect that it had, which was basically just to reflect the grand total for every row in our pivot. And while that may not be terribly useful on its own, it can be useful when the output of that measure is used to build another measure. So to see that in action, let me put region back into our pivot. And now I'll create a new measure that divides our regular order count measure by our order count all regions measure that is immune to any filtering from the regions column. So back to our measures dialog box. I'll call this measure order count % of all regions. And now for our logic, I'll simply divide our order count measure by our order count all regions measure. And then I'll hit check formula. And then because we'll be dealing with a percentage, I'll format our measure appropriately and then click OK. And now hopefully you can see the value of this. Now we have a measure that breaks out the percentage of our overall order count per each region. Now if you're a real pivot table wizard, you might be furrowing your brow and wondering why I didn't just use the show values as % of total feature in the pivot. And while yes, that would accomplish what we're doing here, keep in mind that because this logic is encapsulated in a measure, it's now portable and I can drop it into any pivot table that contains region as a filter. But there's also something else we can do with this that show values as can't touch. So let's remove region from rows and then add in year. But then let's add a slicer so we can filter our pivot table by region. So up to our pivot table analyze tab, I'll insert a slicer and then I will select region name and then drag this over to the side of our pivot. And then I will enable multi-value filtering on the slicer. And now watch carefully what happens when I deselect a few values in my slicer. Our standard order count measure changes to reflect the filtering that we're doing from the slicer. All the numbers in our first column are going down because we're filtering out certain regions. But because our order count all regions measure is immune to any filtering from that regions field, its numbers are unaffected. So in our third column, our order count % of all regions measure is effectively showing us the % of all of our orders coming from whatever regions we've selected in our slicer. So now I can rapidly view the % of our orders coming from any combination of the regions we do business in. If I want to know, say, what % of all of our orders come from just the Mid-Atlantic and Mountain regions, I can clear filters on our pivot and then deselect the ones I'm not interested in. And now we see, with just a few clicks, that just under 31% of our sales come from just those two regions. Giving your end users the ability to get to insights like this within a few clicks is really what business intelligence in Microsoft Excel is all about. All right. Up next, we're going to dive into a whole new class of DAX functions, which give us an unprecedented ability to apply business intelligence to data with a date or time component. I'll see you then.